Now 8086 instructions, and these instructions are flag manipulation instructions. So we'll understand the instructions related to flag manipulation. Here is the list of flag manipulation instructions: LAHF, SAHF, PUSHF, POPF, CMC, CLC, STC, CLD, STD, CLI, and STI. So here is the first one, LAHF. LAHF is the low order byte of the flag register in AH. Now this simply means that we actually loading the low byte of the flag in AH register. AH register is of 8-bit and the flag is of 16-bit in total. Low byte of flag, that means it will contain sign flag, zero flag, auxiliary carry, parity, and carry flag. So these 8 bits of the low byte of the flag will be loaded into the AH register. So flag register will be loaded into AH. So AH will now become the low byte order of the flag. In flag, bit number 5, bit number 3, and bit number 1 is reserved. They do not contain any flag. So these value may be anything, but we only concentrate our study on these 5 types of flags. So we'll only consider these 5 bits while having any type of calculation on this particular AH register or flag register. Second is SAHF. That means stores the AH value in the low order byte of the flag register. So after this operation, flag register will become the value which is having by the AH. So AH will have the value, and that will be loaded, or that will be by default stored in the flag register. So flag register will now become the values which was previously available in AH register. After the operation SAHF, we'll get that the value of the AH register is stored in the flag register. Next is PUSHF. That is, push the flag register's content onto the stack. Now suppose we have stack memory and stack pointer is pointing to this SP location. Since it's 8-bit long, 1 byte long, that means at a time only 8 bits can be moved. So these 8-bit, that means 16-bit flag will have low order byte and high order byte. This is high order and this is low order. So first we'll move the low order byte into the stack memory. Then the high order will be moved into the the high order will be moved first. Then low order will be moved second. So when we are pushing the flag into the stack, that means this will be moved to the SP first. Then this low order byte of the flag will be moved to SP-1, the second memory, and SP will now become SP-2 because SP is pointing to this particular location. Now after this will be pointing to SP-1, and after this insertion SP will be pointing to SP-2. So after this push F operation, SP will be pointing to SP-2. Here is first this byte, this high order byte of the flag is moved into stack memory, top of the stack, and the low order byte is moved to top of stack. And after these 2 bytes movement, the SP will become SP-2. So top of stack will become SP-2. Here is the top of stack is become SP-2. Next is POPF. Pop the top word of the stack in onto the register. Now we want to pop these values into the flag register. So flag register will be of 16 bits. So first the top of the stack will be moved, and then the top of stack +1, that means next byte will be moved. So this complete 16-bit flag is now available from the stack. In that case, SP will become SP+2. So here is SP. Then after one pop operation, SP will become SP+1. After the second byte of the second byte pop, we'll get SP will be SP+2. Clear? Next is CMC, that is complement the carry flag. Complement the carry flag. If carry flag is 1, it will be complement by 0, and if carry flag is 0, then it will become 1. With this we will be complementing. If it is 1, then it is 0, and if it is 0, then it is 1. Next is clear the carry flag. Clear the carry flag, that means it clears the carry flag. It clears, that means whatever the value of the carry flag, after this operation CLC, the carry flag will become 0. So after the operation, carry flag will become 0. If it was previously 1, then also it will become 0. And if it was 0, then also it will become 0. So it simply clears the carry flag, nothing else. Next is set the carry flag. Set the carry flag, that means carry flag will be set as 1. So previously, if carry flag is 0, then it will become 1 because it is set by the set carry flag command, and if it is 1, then also it will be 1. So there is no change in the previous value of the carry flag. Whatever its previous value, it will set the value of the flag as 1. Next is CLD, that is clear the direction flag. We have status flags as well as control flags. So direction flag comes under the control flag. So if direction flag we want to clear, then we'll use the CLD command. After CLD, the direction flag will become 0. Before operation, if it is 0, then after operation it will be 0. If before operation it is 1, then after operation it will be 0. So it clears the direction flag. Next is set the direction flag. After the operation of this STD, we will have a value of the direction flag, that is 1. That means after this STD command, after the execution of the STD, we'll have direction flag set to 1. Next is CLI. CLI is the clear the interrupt flag. Again, interrupt flag is also the control flag. So it simply clears the interrupt flag 0. Now clearing the interrupt flag means that it disables the hardware interrupt. If we clear the interrupt flag, IF will become 0, then it disables the hardware interrupt. We have hardware interrupts, that is NMI and INTR. So it disables the hardware interrupt. INTR pin cannot be read because interrupt flag is disabled. Clear? Next is set interrupt flag. Set interrupt flag. That means it's mistakenly written. It is basically 1. It is 1. IF is 1. When IF is 1, that means the carry flag, the interrupt flag is set. The interrupt flag is set. That means it enables the hardware interrupt. Now the hardware interrupts can be read from the hardware interrupts pins, that is NMI as well as INTR.